And welcome back to chapter 7. This is dedicated for grade 11 advanced student. This is the last chapter for term 2. It's about momentum and collisions. So let's start with the linear momentum. So linear momentum, where we refer to momentum as P, which is equal to the mass multiplied by the velocity. What about the collision? The collision is the conversion of kinetic energy to another form of energy like heat, sound, deformation, you name it, any form of energy. So collision is about where two bodies, whether they are galaxies, atom, balls, cars, hit each other. So after that, after they hit each other, of course, that energy will be transformed to another forms of energy. So we continue with the momentum and second law of Newton. So of course we need to include the force. So F is equal to delta P over dt. Next, we need to connect the kinetic energy with the momentum in that equation, where K is equal P square over 2m. Next is the impulse. Impulse, by definition, is the change in momentum. So that's why we can write that J is equal delta P. So we can write also that F equal delta P over delta T. And as we know, delta P is a J, so we can say that force is equal J over delta T. What about the conservation of linear momentum? Because it's conservation, so of course we need to include equal. So before initial momentum equal to the final momentum. We continue to the two types of collision. As you know, we have the elastic collision and the inelastic collision. Inelastic collision, where the two systems or the two bodies hit each other and each one of them goes in a different direction. In inelastic collision, these two bodies, when they hit each other, they continue as one system. So they stick together after the collision. So elastic collision in two dimension, or also it could be the collision could be taking place in two dimension. And that's it for chapter 7. That was the whole overview about the chapter. And see you in term 3.